All right, good morning again, guys. What we're going to do now is go through the notes for graphing quadratic functions. If you haven't already watched the video where I used Desmos to fill in the tables that go along with these functions, you're going to want to go ahead and watch that first. The notes now have all the tables completed, and so what we're going to do is we're going to use those points, those table values, to actually sketch graphs of the quadratic functions. Okay. Now, as we go through, we're going to sketch these by hand, but you can certainly go back to Desmos or whatever graphing calculator you use and graph the functions and double check and make sure your function looks accurate. Okay. So our first function, y equals x squared, we already have the table completed. And so what these are ordered pairs. So we have a point -2, 4 that's going to lie on our parabola. So remember that x is how far I go left and right. Y is how far I go up and down. And we always start at the vertex. That's the 0, 0, right here where our axes meet. So -2, 4 means I'm going to go back 2, up 4, and I'm going to put a point right there. Then I have a point at -1, 1, so I'm going to go back 1, up 1. I have another point at 0, 0, at 1, 1, so I'm going to go right 1, up 1, and then at 2, 4, so right 2, up 4. What you're going to notice about these, especially the way these tables are set up, is you're going to see some symmetry. Okay, so you should have a highest point or a lowest point, that's your vertex, and then the points on either side of that should kind of correspond. Wherever I'm at on the left, I have a corresponding point on the right. And so what I'm going to do, and if y'all know me, you know that I'm no artist, so these are not going to be perfect, but I'm going to connect them with a parabola shape. Okay, and then what I want you to do is make sure that at your endpoints you're putting an arrow, because these parabolas don't stop where our pen stops. They keep going on and on forever. So that would be the graph of y equals x squared. And again, you could go back to desmos.com and graph that, and it should give you a picture that tells you that you've done a good job graphing this parabola, or that maybe you need to go back and double check something. Now, once we have them graphed, I want to identify some key features. These are the features that we talked about last week in the notes. And so the vertex, that's either going to be the highest point or lowest point. And so the vertex is right here at 0, 0. Okay. This vertex is a lowest point, so it is a minimum. So I'm going to circle minimum. The axis of symmetry is that invisible line that goes through the vertex, cuts that parabola right in half. And so here, our axis of symmetry is the line x equals 0, because it cuts through at 0. And remember that our axis of symmetry equation is always the x value of the vertex. Okay. Solutions, these are also called roots, also called zeros, also called x-intercepts. Okay, and I find my solutions wherever my parabola hits the x-axis. Now this actually only has one solution. It hits the x-axis at 0, and that's the only solution there is. Okay, we can also find roots or zeros by looking at our table. Anywhere where our y value is 0, that x value is one of our solutions. Okay. Domain and range, we haven't talked about in a while. Domain is how far our graph goes from left to right. Range is how far our graph goes up or down. This is all the x values and all the y values here. Now, the domain of all parabolas is going to be all real numbers. This is always going to be our domain when we're graphing quadratics, because they're always going to continue going to the left and continue going to the right. Our range is going to be y is greater than, because this graph goes up and up and up. So y is greater than or equal to whatever our minimum value is. And in this case, the minimum is 0. That's the lowest point on the graph. Now, I'm not super duper concerned with domain and range right now. The most important ones I want you to be able to identify are these. What's the vertex? Is it a minimum or maximum? What is the axis of symmetry? And what are the solutions? Okay, but Go ahead and challenge yourself to try the domain and range as well, because that is something that's going to be a recurring theme, something you're going to always have to be able to find as you move forward, and especially once you get to Algebra 2. And for Algebra 1 as well, it's important that you find the domain and range. These are the most important features I want you to find, but also give domain and range a shot. Okay. Now I'm going to do one more with you, and then the rest will just be practice. So if we look at our second function, we have y equals x squared minus 8x plus 13. And again, I already used the Desmos website to calculate my table values. And so we're going to use those to plot points and sketch our parabola. When x is 2, y is 1. So that means I have the point 2, 1. So I'm going to start at the origin. I'm going to go 2 to the right and 1 up, and there's a point. 3, negative 2. So I've got 3 to the right, down 2. 4, negative 3. So I'm going to go 4 to the right and down 3. 5, negative 2. 5, negative 2. And 6, 1. So positive 6, positive 1. Okay. And so that gives us the general shape of our parabola. I'm going to go ahead and sketch the parabola. Put my arrows at the top. Okay. So now, where's my vertex? Well, here it was at the origin. But here, our vertex is right here, and this was the point 4, negative 3. Okay, right there. So 4, negative 3 is my vertex. Again, this is the lowest point on the parabola, so it is a minimum. The axis of symmetry cuts right through the middle of the graph and goes through that vertex. So the axis of symmetry is the line x equals 4. Okay, it cuts through the 4, and again, it always uses the x value of our vertex. Solutions, we're looking for where this graph crosses the x-axis. Okay, so this is not going to be exact, okay, but it looks like it's at about 2, not quite, a little bit past 2, maybe we'll say about 2.25. And about, we're just this side of 5, so maybe about 4.75. If you're using a graphing calculator at this point, you can double check that. If I graph this in Desmos, you can actually trace, click on points on the parabola, and it'll give you the coordinates. So you might be able to get a little closer even to the solutions. But I'm just looking for a ballpark here. You're a little bit past 2 and just this side of 5. Okay. Domain. Again, for all parabolas, all quadratics, the domain is going to be all real numbers. Okay, so again, the domain is the same for all quadratic functions. Okay, the range is always going to be y. This parabola goes up from its lowest point, so y is greater than or equal to, and then the lowest point is 1, 2, 3 at negative 3. So y is greater than or equal to negative 3. Okay, I'm going to stop there, but I am going to post the completed notes on Google Classroom, and so I want you to try the next 6 as practice, and then you can double check on the notes that I post to make sure that you have got the hang of it. Please don't forget to message me, email me, join one of my Zooms, something. Touch base with me this week. Everybody touch base with me at least once, but definitely as often as you need to if you're having any trouble with graphing quadratics. And I'll talk to you soon. Bye-bye.